Hey guys, we're going to just start off in a minute. Give us a few.
Please. Yep. Oh, I have to get the laptop or the.
Cool.
You don't have to.
Hi everyone, thanks for joining in. We're just going to be waiting for a few more minutes because we have about 200 people to be joining in. We have about 50, I guess. So welcome to this webinar, Machine Learning for Forecasting and Dynamic Pricing. That's the webinar topic. We're going to have three folks actually present to y'all. We have Manju, who is the CEO of Pluto 7, who will be talking about machine learning and how he's developed a machine learning practice for Pluto 7. We have Jonathan from Google, who's going to be talking about Google machine learning in specific, and the offerings at GCP as well, which machine learning is a part of. And we have Sudhakar from Synaptics, who's going to be talking about how they have been implementing machine learning. So just about a few minutes, just give us a couple of minutes and we'll start off the webinar. Yeah. Manju, I'm going to be putting it to you now. You are presenting right now.
Okay.
Yeah. We have 31 people. They're just going live. 1 second. I'm there.
Okay. Yeah, so when Stalker speaks, you...
Okay.
Yeah, well, just when it's your turn, that's all. Like, I'll have to move over when it's my turn also. I wish we brought a mic. Okay.
Yeah, John, I have one guy who's also chat.
Oh, perfect. Okay, yeah. Good. Okay. So he can make sure that the audio and video is fine. Okay, that's perfect.
I can hear that. Cool, the audio is sorted. Let's go live. Let's start off the event. Round of introduction. So Manju, you want to go ahead and introduce yourself?
Thanks, Nikhil, and welcome everybody. And this is a webinar. We definitely want to make this very interactive, and would look forward to having a lot of Q&A. There is a lot of interest in the market on machine learning, ranging from universities to industries to government. So we have some pretty interesting topics here: forecasting and pricing. And a quick introduction we just got. Myself, I'm the CEO of Pluto 7. We are a Google partner, specifically focused on machine learning and AI for industry application. So I'll be speaking first, and then we have Jonathan and Sudhakar who'll follow up as well, right? So just to set a little bit of context, we're quickly going to get you. The first few minutes are going to be context setting, but what we'll really focus at the core of this conversation is give you a flavor of what machine learning is all about from a Google perspective, and including some quick demos from Jonathan, and then I'll walk you through forecasting and pricing use cases. I come with 17 years of experience in the space, applying this in the industry. How does that change with machine learning? things like dynamic pricing and forecasting and so on. So are the topics that we'll go deeper into. And then we're glad to have our customer Synaptics here, who's experimenting with these technologies, solving forecasting and pricing problem as well. Here is what we heard from many of you when you signed up for the registration. You want to know about how forecasting can be done, how dynamic pricing can be done with machine learning, what are the possibilities with machine learning, and you want to know the trends. Hopefully, we'll cover a lot of that in this conversation. So we personally, myself and my company, we come with a lot of background in this space. We have patents on this subject with deep know-how on forecasting and pricing, and that's really our core expertise, right? So we focus on supply chain and retail, solving this for not only the brick and mortar, the large ones, as well as the e-commerce sellers who sell their goods on large vendors, e-commerce platforms, right? So our Google partnership here helps us bring some of the sophistication of the ML and AI algorithms into solving these business problems. If you look at forecasting and pricing, it's an evolving journey, right? It's a traditional problem, as if I may say that, right? In the sense, we have always tried to forecast, right? And it's just that the technologies were different, and as the technology evolves, how we leverage the power of the technology is what defines sometimes a competitive advantage to companies. Now, if you look at forecasting, at least I can say from my experience, I know Sudhakar has a lot of experience in this space as well. A lot of time goes into figuring out having the right data, right? And then, of course, the math behind it. And then comes the power of technology of doing all your permutation and combination of calculations to get to a number that's believable by the end user. So now, before we go into solving these problems, let's have Jonathan, who is our expert, my AI guru here at Google, show you some of the cool stuff that Google does with the technology. Jonathan, over to you.
Thank you, Manju. Super excited to be here. Pluto 7 is one of our very important partners that we work with here at Google. I mean, partners are just extremely important for us because they help us do some of the deployment, the design, the architecture, and we rely on them to basically execute on a lot of the great technologies that we've built here today. I'm going to go ahead and share my screen real quick. And let's see here. Am I sharing my screen? Oh, perfect. Okay. Yep. Great. Let me go. So let's talk about what makes successful ML. We talked about obviously having someone to help you design, architect, deploy this, but three things that being at Google we've uncovered is obviously you need a lot of data. Not just a lot of data, but a lot of accurate data, clean data, data that's been wrangled and put into a good place for you to actually uncover meaning behind it. Having good models obviously is important. Understanding a little bit about how the machine learning works is important, and a lot of compute. It takes, depending on what you're doing, some machine learning experiments can take days, hours, even weeks. So lots of computation can help you accelerate the way that you can find meaningful data. Now, there's a couple ways to actually use machine learning. Number one is to build your own models. I'll do a little demo about building our own models. And oftentimes, customers have very specific needs where out-of-the-box APIs don't work. Now, a lot of the times, though, there are ready-to-use machine learning models, such as our Vision API, which helps to do object identification, helps to identify whether a certain image is appropriate or not appropriate, if there's violence in there. We have a lot of customers using Vision API for all sorts of things. I was doing working with a recent customer that wanted to do interior decoration recommendations. And so they would take pictures of a dining room, and our Vision API was able to identify the fact that it was a dining room, which is, it's not that easy. If you think, even I get confused between dining room, living room, family room, but the Vision API was able to do that, able to identify all the different color schemes, and they were building a application that would recommend furniture and recommend different household items based on the picture that you took. So that's where Cloud Vision API, out of the box, you don't need to do any machine learning. You just send it a picture and it'll give you a lot of information about what the picture looks like. We have Speech API that basically takes text to speech and speech to text. We have Translation API. I think that's a pretty obvious one, right? I recently went to Japan and I didn't know what a certain fish was. I held my phone up to the chef and he spoke some kind of Japanese and it translated it back to me with sardines, right? So that's like, I mean, there's very, very practical use of Translation API. And Natural Language API is the ability to process text and understand it from a machine perspective. So I think we'll be talking about some of that, Manju, sentiment analysis, right? Understanding maybe what is your brand. Some things I'm working on is if I do a hashtag on a certain brand, what is the sentiment on that brand and how is that going to impact maybe sales and demand and supply going forward? And Cloud Video Intelligence API is very unique to Google, which is the ability to process video and provide context about what's going on in the video. Is a person running? Is he jogging? Is he walking? And so taking that video and providing information about what is going on in that video without any human intervention is where Cloud Video Intelligence API fits in. So we'll do a really quick demo here, right? I think we talked about sentiment analysis. And in this demo, what we have is everyone can test this yourself. You can go to cloudgoogle.com, natural language, and you put in something like Pluto 7 helps drive transformational change across the enterprise using AI and machine learning. What does sentiment analysis say? Well, scores 0.7, which is a positive thing, right? And the magnitude is how much emotion is in there. So you can see that it's able to analyze this piece of text and provide some context about what it's saying. And obviously we would act on that based on the business need. Whatever you're trying to do, take this text and make a decision based on that. So given this, if this was on Twitter, you would say that, well, this is a positive thing. They're doing great things. We talked about Vision API, the ability to identify a image and tell you a lot of information about it. For example, in this, we have a baseball stadium, baseball, sports, even athlete, it provides a lot of information about it. And it'll even tell you whether, actually even the location, which is remarkable. And it'll say, is it inappropriate? What's actually in this image? Now, I'll do something kind of very interesting here. So I built a ML model, right, that identifies whether an image is a hot dog or not a hot dog. All right. And this is questionable, right? I think this could be a very contentious debate here, whether this is a hot dog or not. There's a hamburger there, there's a hot dog in there. But my personal belief is that this is a hot dog. So what I did was I built a model, I trained it on thousands of hot dog images, and I had said that I believe that this looks more like a hot dog than it doesn't look like a hot dog. So in this case, we talked about, let's say I had an application where I need to be very specific on, I want to know whether it's a hot dog or not. That's when you would build your own model. If you had used our out-of-the-box API, I wouldn't expect Google to know whether this is a hot dog or not, right? So this is where the Vision API provides a lot of information about it. It thinks it's fast food, sandwich food. You can read all of this, but it doesn't say it's a hot dog. And to be fair, it's really not really a hot dog. But this kind of shows the difference between when and where you would train your own model when you have specific needs versus you need something more generic. So, we have a customer that wants to identify cracks in pipes. That's not something that Google does. We don't train our Vision API to detect cracks in a pipe. This is exactly where you would use your own model and maybe partner with Pluto 7 to understand exactly how you want to build that model and how accurate you want to be, what are your business requirements, what are your technical requirements, and go forward from there. So in the end, Google Cloud Platform has all the technology you need to be successful to build your machine learning model. And it's up to you to figure out exactly what you want to do with it. So that's it for the Google Cloud Platform side.
Okay, cool. Great. Thanks, Jonathan. And let me go and take the control back and share my screen. Jonathan shared some pretty cool stuff, right? And can you see my screen? All right.
Yes.
So Jonathan shared some pretty cool stuff, and Now, okay, now this is something that you see in real life in different ways. Google Photos, Google Maps. Google has about 40 odd products where machine learning is everywhere, right? Now, let's talk something which is much more closer to what we are here for, which is demand forecasting, pricing. Pretty much everybody shops online, I assume today, like if not 9 out of 10 people. And when we talk about shopping online, be it the big vendors or small vendors or companies, the forecasting and pricing is absolutely critical, and so is for enterprises and SMBs of all kind, right? I specifically took retail in this example just to highlight the importance of forecasting and pricing here. Walmart is setting different prices for online and in store, right? And the reason behind that is to optimize the shipment, right, and give the flexibility for the customer. You want it at a certain price, or you want it cheaper. It's up to you. And e-commerce retailers are selling billions of dollars in a single day, right? Amazon does Prime sale in a single day $1 billion, and there was a Chinese single day event and so on. So underneath this, you need all of the machine learning and AI. There's no way a human is going to accurately forecast or set the price when your price points are like billions or hundreds of million price points that you need to decide every single day. Having said that, how do people typically forecast, right? I'm talking about the less sophisticated one, right? Or cases where companies have to make decisions. A lot of human involvement is required, and let's give credit to the humans, right? Businesses are generally complex, right? Data is generally complex, and they have to combine information that they see, right, about if it's a retail or a high-tech manufacturing and so on. They have to look at the information that they see or what the customer said. Even that's data, right? And that goes into your sales forecast, and or what your customers are telling about your product, right? Or the news that you hear. All of this is captured, and the human makes a decision that they are going to sell 200 next month or 300 next month. All of this is information coming in different form. But again, it depends on that human and what experience he has had with that enterprise or a company and so on, to that the bias is embedded into the number, right? And hence the inaccuracies. For the large part, they will be right. That's why they're in the business and job. But sometimes they'll be wrong, which costs the company the money. With machine learning, how is this different, right? If you take the leftmost picture for a second, like if you're trying to squeeze orange out of orange juice out of manually, right? And if you treat that as your way of doing forecasting today, it could be using your current BI tools or Excel or softwares and so on, and you give an input of all these factors that matter for retail. It could be weather, it could be past sales history, your shipments, your bookings, and so on, and you generate an output. If you treat that as one what if analysis, like you ran the forecasting model and it gave you an output and it's one iteration. When you do that one iteration and find out what the resulting output is, it takes you an hour, let's say, to analyze the data and come back, right? You have only so many hours. Your job is not to sit and forecast every single hour for the next 8 hours, right? You have to take actions after that. What changes with machine learning is really this aspect of doing a lot of those scenario planning and for you, right? That's what I put the blender over here, right? To say that you can do a lot of those scenarios and pick the best scenarios that drives your goals. It could be accuracy, it could be profitability, it could be getting rid of inventory. Your forecast has a cascading effect into your supply planning, your customer delivery, and so on, right? So now when you get that, this is a paradigm shift, by the way, right? Like people say, hey, what's the magic behind machine learning? It's like if you go back 300 years and showed somebody a blender, they would treat it as magic, right? That you can squeeze juice out of 1,000 oranges in like 5 minutes, right? It's really that paradigm shift that we are talking about. Now that you combine that with the next level of AI, right? The vision API that Jonathan showed, the video API in retail business, this is happening right now, right? This is not sci-fi anymore. People are looking at the clothes that they're buying, and based on the color of the shirt, they're bumping up the forecast. All of this is being done by the machine learning. Which means what I'm trying to say here is for you to drive forecast, and it's not just for retail, right? In manufacturing, if you see certain products moving forward or being sold more, and or we are working with a beer company where based on how much the beer is sold, they'll produce more, right? The signal from when a customer is picking up the beer can to going back into your forecasting model with the cloud, it's all matter of doing it now, right? So whether you use the hand-based model of squeezing orange or a blender model of forecasting, your fundamentals don't change. What I mean by that is the fact that you need good input like your history, shipments, seasonality, market trends, those don't change, right? And the output, desired output, what you're trying to get to also may not change. You're trying to improve forecast accuracy. You did that for 10 years, 20 years, right? You're trying to do the same thing, except that your input now, you have newer inputs. You always wanted to introduce third-party data, right? But the number of computation that it would take was way too many. So you are forced to not load that or try scanning your customer sentiments because it would be too difficult for you to analyze, right? So now with a machine learning model, you don't have to worry about the cost of computation and number of computation, and you get more real-time planning. You can have the model learn by itself, right? And all of this are possibilities with machine learning. So it's a paradigm shift, and the suggestion is always to let's start small, right? Let's understand why this is different. And it is not about machine replacing humans. It is about machine and human working together. When we drive a car, it's an incredibly powerful machine that takes us point A to point B in a predictable manner. It's car and human working together to accomplish that transportation. Similarly, price. Same philosophy and theory. I started my career at a large enterprise where they have 50 million price points, right? And there's a 100-member team who had to constantly update the prices, and they could never catch up, right? And it's at some point it becomes impractical for you to maintain 50 million price point to optimize your profit, right? There's always justifications that our business is different and so on, but at the end of the day, think about it. You are letting a human decide what the price is. You're introducing, and there's no way they're going to look at the bigger picture of entire product line and decide the correlation between one product and another product selling and so on. This is where machine learning allows you to now think about introducing more data and driving to better pricing accuracy to drive higher profitability and revenue. Again, there is no easy answer. What is easy here is the machine learning models and the platform is ready for you to experiment now. What you have to also recognize is that this is a journey, right? You have to get comfortable with the paradigm shift. And once you get comfortable with the paradigm shift, and then you know how to use it, right? And then you look at every aspect of your business and see how does it make a material difference to my business, right? When we go and solve problems for our customers, it starts with really understanding their business, right? And they have the data knowledge, the business knowledge, and the expertise. And from there on, you build a model. And when they see the working model, whether initially the model is not going to be as pretty as you think, you would imagine it to be. But once they get the concept of the journey and so on, then this is absolutely the way forward, right? So and once you understand the journey, it's the possibility starts opening up, right? If you think of mainframe era to PC era transition, from pre-internet to post-internet transition, what happened to the enterprise? This space, what is expected in 2018, 2019 is expected to be bigger than that, right? Having said that, it's our privilege and honor to have one of our key customers, Synaptics, who's also a Google customer, here to share how do they see this transition. Sudhakar?
Thanks, Manju. Thanks, Jonathan. So, hello, everyone. Move here or...
Yeah, no, you can. So that's the presentation, and this is the video.
All right, just to give you a high-level overview of what Synaptics does, we are a human interface company. typically anything that you interact with an electronic device using your finger, be it a touchpad, or it could be a fingerprint, or it could be a display. And now even we are also getting into IoT, smart home, so the voice. So Synaptics always is on the cutting edge, and it's a market leader. And over the past years, we have shipped more than 5 billion devices that go either into your laptops, or it can be in your smartphones, or it could be on your tablets. So it could be a display driver, or it could be a fingerprint touch, or it could be the traditional capacitive sensing touch that you have seen. And obviously now we are getting into the digital headsets and smart home. So the nature of the business is such that and why did we get into ML, and why did we get into forecasting? As I mentioned, since we are in a cutting edge technology at the forefront of the technology revolution, wherein the time to market is extremely aggressive, and the product life cycles are pretty short. So as you can see, maybe 10 years back, what you're using as a cell phone is quite different from what you're using it today, or in fact, not 10 years, 2 years back. Similarly, what maybe the fingerprint, as you have seen, that how it has evolved over the years from a traditional laptop to into your smartphone. So the key challenge that we face at Synaptics is always time to market and rolling out new technologies. So as Manju was mentioning it, that the forecasting is one of the key elements for us to be able to meet the fluctuating markets, and also to ensure that our inventory levels are pretty optimal. So the more we looked into the traditional forecasting methods that I think previously Manju just mentioned, so obviously, we do have different models. We do have, but there are more traditional based on historical trends, or based on it could be historical customer, maybe relationships, and so on and so forth. So we started looking into what is the other way for us to be in this, to start looking into it, and then we looked into different model, the available machine learnings that are there out in the market, and we chose to move forward with TensorFlow, and then we were working with Pluto. So basically, what we are looking into is that is there a way we can start getting better with our forecast accuracy to obviously better accuracy, and also make sure that our inventory levels are optimal, and we also can start looking into price and say that, hey, why don't we start investing into a more profitable business. So that's when we started getting into machine learning. So it's still a pilot, so we're still trying to look into what's the best way for us. Like Jonathan mentioned, obviously I don't think there are any standard APIs or anything that we can leverage. That's why we're taking the help of Pluto to see if we can come up with a custom model. Obviously, we're going to use the TensorFlow, and then the machine learning, and then start looking into our forecast based on different parameters. And as we have understood that as we get into this journey, so we are taking a very small piece of it, just the forecast piece, not trying to solve all the business problems. And let's start with forecast accuracy, then maybe pricing, and then eventually get into inventory optimization. And then the key thing we understood is the more data we have, the better the model works, and the more clarity we have on what kind of parameters we need to input into the model. So obviously we had a data warehouse with large volumes of data. So we are leveraging that. We are using that data, forecast data, and then now we are working on to modeling it to see, hey, based on the historical data and whatever are the parameters that we have, can we start getting into a model wherein we can start solving our problems moving forward when it comes to the future forward-looking dynamic environment of new markets, new models, new smartphones and cutting edge technology so that we can be more accurate in our forecast, and then we can make better business operations judgment. So it's extremely important that we work with the partner to understand how the model works, how the TensorFlow works, and it's extremely important to work with partners like Pluto. We are working with them to understand how the model works. It's not something that you just put a bunch of data there and then magically it comes out with an accuracy. So we have to, I think that's the key learning so far, is that engage with the partners and ensure that what problem are we trying to solve, and then start working on the model. It's not something that can be done overnight, is our experience so far. But we are already excited, and we are very happy with the kind of results we are seeing. And I think it's going to be a great journey as we embark our future problem solving. All right, so that's all I have for today. Thank you.
Thank you, Sudhakar. And just to emphasize some of the importance that, as Sudhakar was sharing his observations as a customer, as a partner, working closely with a customer who believes in exploration and innovation is equally important. And having data organized saves you time, right? So all the effort that you have put in the past in consolidating data and all those things, this is when you start getting the returns in different forms. So having said that, we'll open up for Q&A, and we'll have Nikhil help moderate the Q&A part.
Right.
We'll look at the questions that come in online, and I guess we'll be responding to that, Nikhil.
Yeah. So guys, I'm checking your feed for questions on YouTube. So some of the questions which we already have of the participants. So the first question, I'm guessing, would be to Sudhakar. Would be, what is an accurate forecast? What is considered an accurate forecast?
Okay, that's a good question. So there's always this debate going on as to, okay, what's an accurate forecast, right? I think at least from our environment within Synaptics, we look into the accuracy of forecast from a lead time point of view, as to from a manufacturing point of view, from an inventory level point of view, as to how accurate is it within the lead time. So that's one metric that we look into. The other, obviously, is from a revenue forecasting point of view, is to how close are you to the forecast at the beginning of the quarter, when you are at the beginning of the year, when you lay down your forecast for the company. So you measure against the actuals, how you have performed from a revenue forecasting point of view. So there are different flavors to that. So more from an operational point of view, business operational point of view, we look at it from a how accurate is it within the lead time, as to when the customers are asked within the lead time. Obviously, you don't expect and the other one is like I mentioned, the revenue forecast accuracy.
Cool. I hope that answered your question. So I see a question from Siva Paturi. Yes. So the question is, can I just get the question in? I'm sorry, I'm just on my phone answering the questions because I can't juggle with YouTube. So
I'll be waiting for the question.
Yeah, just
the journey to drive better pricing and better forecasting is a constant journey. Personally, in my career, there is a lot of there are definitely a lot of softwares out there. One does better than the other, and there are very popular softwares as well. But the core of all of that is really your business, your data, and being practical about your process data and systems, right? will never try to convince or sell you the idea of machine learning and AI will magically solve your problem. It won't. The discipline that you need to have is needed, right? And but what it will do is the following, right? If you have the discipline of knowing what it takes to fly a rocket and you go through that journey, then the rocket can really take you wherever you want it to be, right? So that's kind of how we want to see it. So when you get a car, you get your responsibility of certain things. So this journey will continue no matter what. If your forecast accuracy move from 90 to 92, now is the time for you to question why not 98, right? System is one of the four quadrants that you want to worry about, right? And or leverage, but along with that, hand in hand needs to go the process, your stakeholders, the buy-ins, and so on. Okay.
Right. So, so the question from Siva was, what other inventory optimization problems have you guys solved with ML outside of forecasting?
Okay. What other inventory problems have you
Inventory
solved?
optimization problems.
Inventory optimization problems outside forecasting. I'll take an example of excess and shortages problem, or what Amazon sellers. Okay, let me define what an Amazon seller is. If you take the large retailers, all the Amazon.coms and so on, there are millions of sellers who sell, right? They manage inventory on their own, and these are small businesses ranging from selling $1 million to sometimes 100K to tens of millions of dollars, and they pretty much run these things in Excel spreadsheet and so on. And for them, the risks are very high. If they run out of inventory, they're out of business, right? Amazon ranks them low. If they carry too much inventory, they don't have working capital. So if the shipment arrives too late, it's a 2-day delivery shipment by Amazon. Everything I'm describing applies for selling on Walmart as well, right? So for these guys, the supply chain constraints are extremely tight, and their business objectives are much more broader, saying, hey, I need to maintain working capital. I need to be able to have make sure my customer rating doesn't fall below 5 stars, right? These are abstract KPIs, but when you double click it almost always falls into 3 or 4 areas, right? How well are you forecasting? How are you managing your demand overall, right? And making sure that you're constantly watching your demand and your demand sensing your customer feedbacks and so on. Then how are you watching your excess and shortages, right? Obviously, they can't watch every hour. Humanly, it's impossible. They don't have IT organizations, right? So when we start solving for these guys, it's literally we have to look at all kinds of our supply chain theory books and come back with answers using machine learning and AI, right? So, which means what I'm trying to tell here is it's an end-to-end value chain that we had to look at to solve for these guys. When we go into larger enterprises, typically we have a more structured use case, but when it comes to SMB, we have to look across the supply chain. Okay.
Yeah. So more questions coming in. So I'm not sure who this is addressed to, but this is by Tariq. He's asking, are there any recommendable tutorials, online courses, GitHub repos where examples of working algorithms are shown? If that doesn't exist, what type of neural net or learning algorithm is recommended?
That's an incredibly loaded question, but I guess between Jonathan and me, we'll try to answer those.
You start first.
All right. So we are a Google partner, so we'll start with Google, right? So Google has 25,000 algorithms that they own, right? And if you think of an algorithm that needs to solve a certain problem, it is in some form of shape already with Google, right? If you look at the 5 other major companies who use AI, right, and I don't want to name those here, a lot of the problems are already solved, but it's just that it's not solved in the context of supply chain, right? Neural network models, there are like, 20 odd models. So first of all, to your first question, start with cloud.google.com. There's a lot of documentation available there, right? That should give you a starting point on how to go about with it. When it comes to neural network models itself, there are a couple of universities I personally watch closely, MIT, Cambridge, and so on. So to see what kind of research papers are they publishing. When it comes to industry application, out of the 20 or 30 odd models that we have seen, It is really about 3 to 4 models that matter the most for 90% of scenarios. And you'll be surprised how simple a model sometimes you need to solve problems that will have huge benefits, right? So that's the second part of the question. Was there a third part as well?
I mean, what type of neural network or learning algorithm is recommended?
It really depends on your business, right, and what you're trying to accomplish. And on a mathematical aspect, how much computation do you need to get to before you get your answer, right? Unless you go through the journey, it'll be hard to get a specific answer for you. Jonathan, you want to add?
Yeah, I mean, yeah, it's a very technical question, but also, I mean, very dependent on your business. I mean, a lot of people say, for time series, you use recurrent neural networks. For image recognition, you use convolutional neural networks. For a lot of other things, you use just, the basic deep neural nets. So I think my suggestion to you is do a couple things. I learned a lot from looking at Kaggle. Kaggle is like an open source, open platform. You can look at different data sets, and these are machine learning, basically open source data sets that you can look at and look at how other experts in the field are processing, analyzing, and making predictions on a lot of that data. So Kaggle is one of them. Number two, if you just search cloud ML tutorials, there's a lot of different tutorials that walk you through exactly real life examples of how to use deep learning, how to use machine learning. Number three, you can do a quick search for Data Lab, Google Data Lab. If you look up Google Data Lab, it's our Jupyter Notebook, and Jupyter Notebooks are, I would say, kind of like the de facto standard for experimentation with machine learning. And so with Data Lab, we have a lot of examples inside of the Google Data Lab. Basically, when you use Google Data Lab, there's going to be a lot of examples that are inside of that Jupyter Notebook. But I mean, yeah, there's a lot of tutorials, and I think the question is very open-ended. But definitely, take a look and see what else is there.
Cool. There's another question. I think, Jonathan, you can take this from Rajeshri. When a dataset feed is given into ML from a customer's perspective, does it give various options for the models which you can use off the shelf?
Yeah, so I think that's more based on which platform you use. So, for example, with Google Cloud, I mean, TensorFlow is kind of our standard. And so within TensorFlow, you can use all different libraries that may address whatever machine learning workload that you're trying to process. And like I mentioned before, there's different types of machine learning. You can use, convolutional neural networks, recurrent neural networks. And so we've built these high-level libraries so that you don't have to go into the math, right? It's very mathematically intensive, these algorithms, and we just build libraries that are basically API calls. But that's kind of, I think that's the right answer to what you're asking is, are there kind of, models that we can use? And yes, that's kind of where TensorFlow comes in. Cool. And I see Sudhakar nodding your head. Is like, what are your thoughts?
From a customer's perspective.
Yeah, because I think that's how Synaptics has evolved from a neural network company.
Yeah.
As to how you can, kind of learn from our neural network within our human body. And then I think that's how we evolved our products.
Yeah.
And then, like you mentioned, I think there is no straight formula.
Yeah, there's no right answer.
You just have to keep working on the model,
right,
and understand what are the parameters that will help you, and let the machine look into everything and come up with.
Yeah, and there's several ways to the same answer. I mean,
right.
And so a lot of it, unfortunately, is a lot of experimentation.
Exactly, you have to have patience. You need to have a lot of patience. That's what we understand.
Right, and the more knowledge you have about machine learning might accelerate to that end goal, but there are still multiple ways to get there.
Yeah, and this iterative, the fail fast mechanism, right? As in, get the input in, use one model, use the model that you understand first, right? And look at the output, and why do you think the output is bad? Is it because the input is bad or the model is bad, right? So if the input is bad, keep correcting the input first, and if you did all your due diligence with the input and look at the model, right? Then graduate to the more and more complex model, right? Some of the CNN and some of these ones are, they do so many layers of computation that to trace back is going to take an effort, right? So But again, for the math geeks out there, it's a fascinating world.
So, I mean, there's a follow-up question on this. So, does it recommend? Categorically, they're asking, does it recommend a best fit model? I mean, a best fit model. Yeah.
That's
I don't know how to answer that.
So exactly.
Maybe that's an
right?
idea for Google.
Yeah, I mean, so this is not a secret, but Google's been working on this thing called the Auto ML, and that pretty much iterates through many different models to find that best fit for you, and that's something that is high in our something that we're definitely looking at, because we did talk about a lot of it experimentation. Why not automate it? And so we understand that problem from a technical perspective and a business perspective. You want to find answers quickly, a lot of experimentation. We want to remove the human aspect to it, because a lot of it is kind of tedious. And so, yeah, that's something that we're definitely looking at. But I mean, right now, if you want, a lot of my customers are just kind of writing their own scripts to run different models and then seeing the output based on that by themselves.
So I would like to make one comment based on the series of questions. Right? These are fantastic questions, right? And obviously, folks are really doing their research and spending time on this. There's a perspective that I believe in as we try to use these models, right? Is how far is the gap between human way of doing things and a machine way of doing things? I'll give you some examples, right? When you have Gmails classifying spam versus not spam, right? That's a massive machine learning model digging through the text and correlating and coming up with a very simple classification. And at the scale at which they need to do for 1 billion users, like Google uses some of these incredibly complex models, right? And similarly, you can go through the 40 other key products that many of us use on a daily basis. When it comes to pricing and forecasting, right, it is heavily human-centric. It's on the other spectrum right now. This is my personal belief. Few companies really use machine learning, AI, and some of these complex models to solve this. Why? Because it impacts their business so directly, right? Bad forecast can lead to excess and shortages and obsolete products, or wrong price can lead to profitability loss and so on. Right. So when you start dealing with this, the humans, the general tendency is, oh, I want to decide this myself, right? I can't let a machine decide this. This is how we drove our cars for since, I don't know, for decades, right? Now we are starting to get comfortable with self-driving cars, and eventually self-driving cars are going to become more safer than humans who is texting driving. I had a dent in my car just on the way to here, right? I mean, such mistakes happen. So the point is, and that's real, by the way.
Yeah.
I just had it in the garage, right? So the point is, how do you give this control to the machine, but where you believe the machine? That's where you need to work on these models methodically, right? Go ahead.
Yeah, I really like this question. Sachin is asking this question. How can ML help in case of NPI or brand new offering when there is no sales history? What kind of inputs ML needs from a planner in such case?
So I'll give you my one first, the traditional way of thinking, but I'll let Sudhakar, I know he has a lot of background in this, right? Traditional way of doing is, if I'm launching a new product, what is the other product which is closest to this product, right? I have a blue shirt, there's a brand new shirt, brand new SKU name, brand new price, right? I've sold a whole bunch of yellow shirts before. Are they close? Is the same customer going to buy, right? So that's one way of chaining products to come to a forecast, right? But that's looking for the obvious signs. But the not so obvious signs is, if the cost, if you're buying diapers, and then the customer also buys potato chips, right? I mean, they're two extreme products, right? But if there is a patterns of customers buying this, and if that's what your data says, and when you're launching a new product, you want to look at even those, right? I'm going to the other extreme of how Amazon AIs work and so on. So although you're launching a new diaper and you're looking at potato chip sales, right? It makes no sense. But it happens to be the guy who has 2 kids, and with kids, he's at home and is changing diapers and is watching TV and he eats potato chips, right? So things like that. So you want to look at potato chip sales and plan your diaper sale, right? I mean, it's like, even though it's a brand new SKU. So these are kind of things happening in the market, but I know you don't deal with such scenarios? But I'll let Sudhakar tell him.
That's a good question. So we kind of have come to a point in our model. We are facing the same problem as to like I mentioned before. We are in this cutting edge, new emerging markets and new products that don't have history. So part of the things that we are trying to look for is obviously we are thinking that an existing historical trends may not help us. So what we are trying to model that, I think we're working on that, is we still don't have an answer, but we are getting there, is to go back and then start entering the external data that is not very specific to our company, which makes sense that similar NPI products, if they have gone through, if there was a path-breaking product that happened 2 years back, a driverless car or something like that, and if there is what kind of trends did it create, and what kind of impact does it have on a given customer. So we are trying to take certain external data sets, and which is not belong to our company. We try to bring in that, and then see if we can start building the model it's a combination of what you know from your data set and also from an external data set, and then start looking into what are the different parameters, and then we're trying to build the model. And we believe that we are getting closer. Actually, I'm very excited about the kind of results that we have started seeing, that we will be able to, I think, share more later on, but I think we're getting close to for NPI products. But that's the challenging. NPI, not only for an existing kind of a product line that you're launching a little bit a new version of it, but if it's some completely new set of technologies and it does not have any history, it's just entering a new market and a new product. Right. So we're trying to build some correlations somewhere. So that's where I think the key. I think our use case is we are not able to do that ourselves with an Excel spreadsheet or some algorithms that we can. That's why we want to leverage the ML, and that's our key. I think that's one of the key things that we are looking forward to.
And in all of this, right, and working with Sudhakar and his team directly, getting the basic ML infrastructure up and running, that's the easy part, right? Yeah. It's all in Google Cloud, and you just turn on the instance and you get your basic data and show how the model runs. The harder part is what Sudhakar just described, right? Understanding the business, understanding the data, understanding the product, which version correlates to which version, and then understanding the power of computation that you have with the infrastructure that you put, and saying, now let me experiment with these things and see what kind of things that I can get, which I couldn't get before. Okay.
Yeah. So another interesting question from Abhishek: is it all linear regression? What happens when the data isn't linear?
First of all, I have a lot of respect for linear regression and all these basic regressions, right? Because the question was, is it all linear regression?
All linear regression?
If it doesn't work, what do you do, right?
Yeah.
So, okay, then you if you Google this up, you'll see, like logistic regression and a whole bunch of other ones, right? I think LSTM model, LSTM model, ARIMA model. There are a lot of these models which solve time series problem. But the way I would say it is, okay, before you decide whether linear regression or some regression doesn't work, go back and really understand how does a human being who does this job do the math today, right? And I deal with a lot of these customers, SMB customers, so they do everything in Excel, right? And they struggle, right? And it's like, okay, how do you scan your data? The very basic thing I ask is, if I give you like 5-year history, you have 5 years history. How do you decide what the forecast number is for 3 months down the line, right? And many a times you'll be surprised, all they're doing is few months moving average, right? Few months moving average, or looking same period last year, based same period, if there's any seasonality last year. That's all they're scanning in their Excel spreadsheet. When you look at these regression models, right, and at least regression models, you can look at many columns and it tries to find patterns and saying which one seems to be more significant and so on. 8 out of 10 times, the math is done based on just scanning through 2 columns, right? So before you look at other ones, try enough with one model and then go to the next model. So some of these answers, which one is better, is really subjective on the data you have and the problem you're trying to solve, and what is the accuracy level of the results you're trying to get to.
Yeah. And the last question I'm going to take from AI World. I'm guessing this is addressed to Sudhakar. Have you any numbers? How effective was it in was the ML service to help you out? Was it increased by 15% your forecast, or is it double the accuracy?
No, we're still,
Yeah.
it's still early days. It's just that we have embarked on this journey, right? So it's not something that you can. So we are applying the model to the future forecast. So we had the machine learn based on what we know, and then now we are applying to that. So I don't have the numbers right now, but obviously I think that's, in fact, I was talking to Manju before this, that as early as I think on next week or December 1st week, we would like to get to that point wherein you don't take one or two kind of futuristic forecast data sets and then come up with a number accuracy. So we need at least consistently to measure that for about 3 months before I can come up with that number. So, but we are really excited that we are getting to that phase wherein we can measure that, that we are letting the machine now predict the forecast, and we start measuring against, like he said, based on our human regular process, what is the forecast, and now we are measuring it. So I don't have the number right now.
Yeah, and part of this our journey working with our customer is really collaborating on understanding business and also setting the ground realities up front, right? It's a little bit of a job of, like somebody gets a stock portfolio of past performance and says, how much money am I going to make in next year, right? So it's when you predict, you have to not only look at the past performance, but also like how they make decisions, right? Just like how you make decision on when to buy, sell, like it's similar decision patterns you have to understand, and then see, can I model some of this, right? Or should I not model and let the data patterns say that you made decisions, and the data patterns is saying that if you had let it on its own, right, and you would have landed up here, right? Maybe you would have made more money, right? It might not, everybody in the company might like this kind of news, but that is the point that Sudhakar is saying. Okay, it's a journey, right? We're going to see how this machine performs 1 month, 2 months, 3 months, and at some point, if the machine does a better job of it, because every week it's going to record. This is the important aspect, right? The TensorFlow that you maintain is going to maintain a version of it every week or every day or every hour, whatever you want, right? And there is going to be a point in time verification you can do. You fast forward, 9 months into September of 2018, right? You say, what did this machine tell on January 1st, right? That I'm going to do. What is it telling today, right? And what did we actually ship, right? When you look at it, you'll know. And if the machine did a better job, then you need to find out, even that you need to find out why it did a better job, and then go change your organization behavior. If a machine did a terrible job, then you need to find out what was wrong with your input or your model, right? So now this journey is more important than the enabling the model, right? To just launch a model and say it's working, that's only one part of the solution, but it's really this aspect, right? Why companies are thinking deep about this transformation is because this can change your organization. This can change how people do their job, right? And when you put the power of the business know-how that organization, sales, marketing, finance, and all they have, plus with this, it really helps them make better decisions. So you have, I think, 3 more minutes.
Yeah.
Nico?
I think I'll sum it up. I have a personal question for Jonathan, actually. So we've been doing a hackathon in just as our organization, and we've been testing Google Vision API.
Mhm.
And so what we've realized is that it predicts images based on web images, right? Most of the time.
Okay. Yeah.
So it gives you an accuracy level based on what images it can find on the web.
Mhm.
So is there? I mean, like now you're coming up with video API, and it's already up there. So is there, can you cite some examples about how extensive is it getting in terms of video API, recognizing live imagery and, predicting, multiple decision science?
Mhm. I guess maybe how would you measure when you say extensive, what's the measurement that you're asking about? Like, how would you measure extensiveness?
So, I mean, the use case which we gave to the students here was basically multiple images of people wearing brands that aren't known,
Mhm.
and Google wouldn't understand the brands that aren't known, right?
Got it.
So, and probably even images that aren't so clear.
Yeah.
So, what is the level? Because you cited the baseball stadium example,
Mhm.
right? So, but I'm guessing that's from the web.
Mhm.
So, how extensive are you all going in terms of making it more decision science? And,
Right.
like how does what's GCP's input in that
Mhm.
area?
Yeah. So without there's some really cool things going on internally, and I wish I could share everything, but that's a well-known problem, right?
Yeah.
Customers are going to say, "Hey, I want to know when my logo is appearing somewhere else."
Right.
That's something that we know of, and we're actively working on.
Okay.
It's not, that's a very common thing. So it's going to be impossible for Google Vision API to be able to detect everything in the world.
Right.
So we're it's an active research that we're going to look at and hopefully expose it to the public in terms of how do you basically train your own models, but leverage our existing set of classifiers that we already have in our system.
Yeah.
So yeah, that's something I wish I could share more.
Okay. Cool.
But one thing we all know that you have the most amount of third-party data.
Yeah, I mean, there's a lot of data, and that's one of the three things. Yeah.
So I'll just summarize. I think thanks a lot everyone for joining in. Thanks Jonathan. Thanks Manju. Thanks Sudhakar for giving us a lot of insights. Just to summarize, it's experimentation, machine learning, data science is a way of it's ends. It's not your end goal. I mean, you have to experiment a lot. There's a lot of data sets which are available freely. Use it. Kaggle was one example which Jonathan cited. Get into the mode of figuring out what you get results with first, and then obviously then scaling it up further. So with that, I'm going to end this webinar. You can always ask us questions on these email IDs. Visit our website, write to us. That'd be great. Thanks a lot, guys. Thank you for your time.
Thank you.
Thanks.
Thank you.